Welcome to Stats with Chaz. I'm Dr. Charlie Collins. Today, I will provide an introduction of social science statistics. I will briefly cover the role of stats in social sciences, the scientific process, the application of statistics, then I will go into more detail about variables and types of variables, as well as the measurement of variables. First, let's talk about the role of statistics in the social sciences. Why study statistics in the first place? Because it is a central component of social scientific research and inquiry. Research helps social scientists answer questions. There are many forms of research. Quantitative research is one form of research in which scientists collect numerical data, so it's numerically based. Statistics helps researchers analyze those data to answer research questions and test theories. Before we get into specific forms of quantitative data, let's talk about the scientific process. There are four basic components to the scientific process: theory, hypotheses, observations, and empirical generalizations. Theories are rigorously tested explanations of relationships and other social phenomena. Theories are much more than everyday informal explanations for things or simple hunches. Ideas become theories when they are extensively examined in a scientific and rigorous way. Hypotheses stem from theories. Unlike theories, hypotheses can be everyday explanations for things or ideas. But in the social sciences, these explanations should be informed by theory. Scientifically, hypotheses take the form of statements of the relationships between variables. To test hypotheses and to continue the theory-building process, we must make observations. In quantitative research, we would collect numerical data about the variables outlined in our hypotheses. We can then use statistics to analyze those quantitative data. Finally, the analysis of our observations allows us to examine other trends in our data and generalize those results to the theory of interest, to broader populations, or allow us to develop further hypotheses. This is what we consider empirical generalizations. Now let's use a specific example of conformity theory to highlight the scientific process. Conformity theory states that individuals have the tendency to match the attitudes, behaviors, and beliefs of the group to conform to group norms. This is a very basic theoretical statement. Individuals conform to the norms of the group. Drawing on this theory, we want to state a hypothesis. Because there are a variety of different ways to conform to groups, we must identify specific ways to test conformity. A hypothesis around this may state something like, individuals will choose the incorrect answer if other members of the group also choose the incorrect answer. Using this hypothesis, we can set up scenarios that allow us to observe these behaviors and to collect quantitative data, and then analyze the data that we gather. Finally, the results of this analysis allows us to generalize and build a theory. So, next time, perhaps we examine conformity to preferences of food, to the group norm, or something similar to that. To move through the scientific process, quantitative researchers use data in the form of numbers. These numbers come from what we call variables. Variables are characteristics that can change from case to case, person to person, and/or over time. Some variables are more objective and standardized, while others are more subjective. For social scientists, many of our variables are characteristics about people, which include things like behaviors, cognitions, perceptions, and opinions, for example. There are two basic types of variables: discrete and continuous. Although statisticians will debate about whether a variable is discrete or continuous, the basic rule of thumb is that the discrete variables are those that are always measured by whole numbers and cannot be subdivided, whereas continuous variables can be subdivided theoretically infinitely. For example, if I'm measuring the size of a parking lot, I could use a discrete variable and count the number of parking spots, or I could use a continuous variable and measure the length and width of the lot in meters. As you may have noticed, both of these ways to measure a parking lot are both numerical in nature. You may be asking, how would a social scientist take something that is qualitative in nature and not numerical and actually make it numerical? You may also be asking, considering that variables social scientists use are things like behaviors and opinions that are not numerical, how do we make them numerical? This brings us to what we call our level of measurement. The level of measurement is the quantitative or mathematical nature of our variables. Some variables, like number of spots in a parking lot, or income for example, are already quantitative. Other variables like gender, political preferences, or religion are not quantitative, and therefore we have to turn them into quantitative numerical numbers. Because of this, social scientists will give them quantitative scores that are not necessarily numerical, but are rather numbered labels to represent a particular score. For example, if I'm interested in religious affiliation, I may assign Catholic the number 1, Muslim the number 2, and Protestant the number 3. The numbers are simply quantitative labels for those religious affiliations. These numbers allow us to quantitatively analyze these variables. There are 3 basic levels of measurement: nominal, ordinal, and interval ratio. These different levels of measurements help us figure out how we can analyze the data we gather. Variables measured at the nominal level are non-numerical, and scores given to these variables are representations of non-numerical categories. Nominal is the most blunt or rudimentary level of measurement. There are 3 criteria of nominal variables. The first, all categories must be mutually exclusive, meaning a case cannot fall into more than one category. For example, if I'm asking again about religion, I cannot create categories where a single individual can be assigned to 2 religions. That person must fall into one category. 2, the potential responses must be exhaustive, meaning all individuals must be able to fit in one of the categories. Again, if I'm asking about religion and I forgot the category atheist, the atheists will be excluded. I must make sure that all individuals can respond to at least one of the categories. And third, all potential categories must be similar, meaning the cases are truly comparable. Again, in asking about religion, I would want to only include religions at the same level, such as Protestant, Catholic, and Muslim, for example, and would not want to include specific denominations such as Baptist, Evangelical, or Shia Muslim. Now, moving on to more sophisticated levels of measurement, let's talk about ordinal. Variables measured at the ordinal level are very similar to those measured at the nominal level. The main difference is that the categories of ordinal variables can be conceptually ranked, whereas the categories of nominal variables cannot. For example, if I'm interested in a college level class status, my response categories would likely be freshman, sophomore, junior, senior, and postgraduate. I can give these scores of 1 through 5, 1 representing freshman, 2 representing sophomore, and so on. Conceptually, these categories can be ranked. Sophomores have more college credits than freshmen, juniors have more than sophomores, and so on. Like nominal variables, variables measured at the ordinal level still give quantitative scores to non-quantitative categories or qualitative categories, but these categories can be ranked in some conceptual way. Much of the social science research falls within this category because we often ask survey questions like, on a scale from 1 to 10, how much do you agree with the following question? And then we proceed to ask a question. Finally, the most precise level of measurement is the interval ratio level. Interval ratio variables are actually numerical variables. There are 2 criteria for interval ratio variables. 1, all scores have equal intervals, which means that the distance between scores 1 and 2 is the same distance between scores 2 and 3. Second, interval ratio variables have true 0 points that indicate the absence of something. For example, if I'm interested in daily exercise in minutes per day, and a respondent says 0, that means there's an absence of exercise. 0 means something and indicates something. Okay, I get it. There's a lot of information here. So let's sum it up. Social scientists lean on the scientific process to ask and test hypotheses. We make observations and contribute to the theory building process. For quantitative research, we use numbers and variables. Variables form the basis of our research, so we like to turn anything into a variable. Literally, I can try to turn anything into a variable. To do this, we use levels of measurement: nominal, ordinal, and interval ratio. These levels tell us how we can analyze the variables that we have. This informs all of our data analysis and is extremely important to quantitative research. I hope this has been informative. Thank you for watching Stats with Chaz. I am Dr. Charlie Collins.